Porter, and like I said, I've got Curtis will be on here shortly to go over the AccuCom, like Dave said. We're going to go through the basic stuff with GOV10 and AGV5 also. And then we also have a lot of talent on this site today from the names I've been watching. So if you do run across any questions, feel free to break in and ask them, because what we can't answer on our end, I'm sure there's somebody out there that probably can. So we'll go ahead and get going here. So. Okay. Well, first one we're going to go through is we're going to talk a majority of on the GOV10, because it's a little more complicated than the AGV5 is. So these are digital controls that are designed to operate a fuel-injected natural gas engine on with new capabilities and advancements. It stabilizes the engine over the old mechanical linkages and the old hydraulic governors. It's a great improvement if you haven't had a chance to operate one of these on one of these large old slow speeds, or on some of the Superiors. It works there great also. So that improves the efficiency on it, and it eliminates a lot of the mechanical maintenance that you would have in the past. So. Fuel control systems based on a digital control technology eliminates mechanical components on the engine, like we talked about, the actuators, the linkage, and pre-existing mechanical fuel valves. It reduces maintenance associated with the costs and improves overall control and stability. It makes the engine start easier because it's got more control over a smaller amount of fuel, instead of running a big choke block valve that they've used in the past. And then they'd have to deal with the hydraulics of the governors like that. Being it's all done with electronics internally, everything works much faster, and we can fine-tune that stuff to a lot tighter, smoother control. So both systems are Class 1 Div2 in a Group D, so it can be run in a real hazardous environment. And the one that's shown is the AGV5 valve. That's a valve. It's all by itself. It has no controls to it. It reads pressures, but to control the valve, you need another source, either a PLC or another type of controller. So we'll get into a little more of that later. So these are the two product lines. There are actually four of them there. We have the GOV10. Is a standard valve, and then for the really large engines or low manifold or supply pressure, they utilize the GOV50. Basically looks the same, just some of the internal parts are different, and it allows to flow more fuel than the standard GOV10. Now the AGV5 comes in two sizes, one up to like 3,500 horsepower, and then the one's up to 10,000 horsepower. And if you do have an older version of that, of the Dash 2 unit, and you are having some trouble maintaining speed on a large engine, we did an update here a number of years ago where they've opened up the orifice on that a little bit to pass more fuel to it. So if you are having that problem, please get a hold of us, and maybe we can check in on the serial number on it and see whether or not that's been modified or not. So we're going to go through the GOV10 first. The nice thing about the GOV10 and the GOV50, it's a standalone governor. You don't have to have any outside control mechanisms to it. You need a 24 volts to power it, and then you need a speed input, either off the flywheel or some to give you the RPM on it. But all the controls, all the adjustments and everything else is built into the valve itself. So it's a superior valve to control the engines over the old mechanical devices. It's rated up to 15,000 horsepower. And it's also rated at a working pressure of around 75 pounds and a maximum not to exceed is 200 psi. One thing to keep in mind if you are operating this valve, it uses what we call muscle gas to operate the poppet and stuff on it. That keeps the amperage low on the valve, and it requires at least 25 psi pressure above the header pressure. So if your header pressure on some of the large slow speed may be running at 50 psi, you got to keep at least 75 pounds on the valve itself to make this the internal parts of this work on it. So keep that in mind. There's 3 ways to control the speed on it. One, you can do it from the display. Then you got a 4 to 20 that you can bring in to control it from an outside source, or you also can bring it in through the RS-45. Yes, from a control device of some sort, a PLC or like that. So, and then there's also a manual override for if you needed to control it from the display. There's a digital in on it that you can hit to bring you back to a local speed control on it. So. Benefits of it, it's a complete standalone, like I mentioned. All speed controls algorithms are built into it. It reduces maintenance costs by eliminating moving parts, including the existing hydraulic governors, fuel actuators, and the linkage. It's a very fast activating valve or acting valve, and improves control and the stability of the speed and load of the engine. So as load changes, it reacts to it very fast to keep the engine stable. Digital controls often improve speed stability and manage of load changes. One of the newer things we've added to it is we've instead of having to run the wiring inside the case now, we're putting cannon plugs on it, so it eliminates the need of people having to take the cover off and getting there to wire it there. We've also done that with the AGV5 also, so it makes it a lot easier to set it up and easier to change out if you need to bring it in for maintenance. Another thing we've added also is we've added a filter, if you can see it in the picture there, where we're filtering the muscle gas coming in. So if you have some crappy, dirty gas in there, it helps eliminate the particles of stuff from getting inside the valve that is needed to control it. So these also can be, by changing some orifices or some plugs around, these also can be operated on shop air, as long as the shop air is 25 pounds above the supply pressure on it. So another way to keep the valve clean. So also, it's a fail-safe. If it loses power, it's got a spring inside of it there that closes the poppet that shuts the engine down. It is not considered a shut-off valve because to make this valve work, we need to isolate the gas from it at startup. So you'll need some sort of a block and bleed valve connected in series with this, so we can de-energize or blow all the gas out of it for starting purposes on it. So another picture of that filter up there on the side on it.
Hey, Michael.
Yes.
Could you kind of explain to them why we had to have that zero pressure and that bleed off on that valve?
Well, it's got the newer version on it there. It's got a self calibration on it. So when it gets ready to start, it's looking for zero pressure on the supply gas and on the manifold gas, so it can zero the transducers inside of it. And that's not real important when it comes to the large engines that have high fuel manifold pressure to light them off, like a Cooper may run around 10 to 12 pounds. But on the Superiors, they start on less than a pound of gas. So we need
Quarter pound.
What's that? A quarter pound?
Quarter pound.
Yeah. So I mean, we really need a real accurate number in there to get that thing to light off right, and they do extremely good job on it. But every time you go to a start mode on it, when it gets to the ready mode, it's looking for zero gas in that valve, so it can re-zero those transmitters on it. So that's really important.
So if the block valve does not bleed off, and you still have, say 40 pounds or whatever on this thing, when it zeroes, it thinks whatever pressure is there is zero. So, and the reason I bring it up, because most of our calls that we get when they cannot start their engine is because they're flooding it, because, if it thinks, say 10 pounds is zero, then it starts adding fuel on top of the 10 pounds, and, then it's a bad situation.
Correct.
I think we had couple weeks ago, bring that up, and that was the problem.
And you can see in this picture here where they've got the block and bleed here on the valve. So this area in here needs to be with zero pressure on it, so the valve can go through and recal itself on it. So again, you can get away with it in some cases, but if you set the valve up right when you're programming it at the beginning there, if it senses any kind of high pressure, it won't allow you to start the engine. So point. The GOV10, the governor on it, the display is, you don't need the display with all the newer PLCs and stuff that are out there now. We can communicate directly to the valve. So if you want to build some type of graphics or something along that line in your newer PLC, or maybe a DE4000, we can tie directly to the valve to do that. So, and then again, I mentioned earlier, there's an external gas kit that comes with the instructions and how to set this thing up, so you can actually get, if you want to get a cleaner airflow or gas into the control of the valve, we have a kit available to do that. So, and then we also mentioned, about the harness that we supply, so you don't have to get inside the valve anymore. So you can mount the valve either horizontal or vertical. If you wanted to use the fuel flow orifice in it, we recommend you needed a certain amount of straight pipe to do that. And you can see the way this one's set up here, you may have to calibrate the fuel flow on this a little bit, because you don't have a lot of straight pipe coming out of it. So it does not affect the performance of the valve any. It's just when it comes to measuring the fuel going out. If you're looking for an accurate fuel measurement on it, you need some straight pipe going in and out of the valve, so you got clean flow without any turbulence in it. So keep that in mind if you plan on doing that or using that portion of the valve. So display, you're probably used to most of them. It's our standard display. The size and everything, it's the same size as a DE would be, the older DEs, and the AGV5 footprint on it. So you can you can program it all from the display. You can speed it up, slow it down from the display, do the troubleshooting from the display, or all this stuff can be brought in with register numbers into a PLC to do all that also. It's pretty easy after you played with one a little bit to go through and from the different pages and stuff on it. To get in there and to change any kind of settings in it there, you've got to hit the F1, F2, and then setup button to get into the program itself if you want to do any modifications on it. This just gives you the layout of the valve. You need a speed pickup on the flywheel to bring that in. And then you need, of course, you need the 24 volts. It's a very, because it's being powered by the gas itself, it doesn't require very much amperage. It's only around 2 amps it operates on. And then you've got the Modbus communication that comes out of it that you can read a lot of the shutdowns and alarms and stuff on it, and also control the speed with it. And then it's also got a flow capability. It's a 4 to 20. You can scale it, and then you also can read the RPM on it too. It will give you another 4 to 20. You can scale that for the speed also on it. It has a warm-up feature on it that you can program in, so when the engine starts, it will stay at a predetermined, pre-programmed RPM until the warm-up timer is satisfied. But if the engine has gone down and you want to restart it quickly, you can go in there and bypass that or turn the timer off so you can get back online quicker. One of the neat features on it and the control setup on it is it's got a kick on it, we call it. So when the engine starts to start and the valve slowly starts to open up, you can pre-program a kick on it. So if you know roughly where the position is when the engine's idling, you can force the valve to go just below that a little bit, and then it will ramp up to the area where it will light itself off. That eliminates a lot of the cranking time it takes to get the valve from fully closed to the operating range on it. It's a really neat feature in it that does that. So it also is designed to purge the engine before it allows you to open up the fuel valve. That's another part of it that can be programmed into it also. And then the idea with the ramp on it there, when the engine starts cold, the light off pressure may be at, let's just say 10 pounds, and when the engine's hot, maybe it will light off at 8 pounds. Well, having that ramp feature in there, you can bring it up slowly, and then it will, when it gets to the sweet spot there, it will take off and get the engine up and running. So instead of just having one set point, this one here, it varies. And another neat thing about the valve too is there's the governor part of the valve, and then there's also the starting part of the valve. The starting part of the valve will look at either fuel pressure, predetermined, or we'll look at fuel flow. And one of the nice things about fuel flow is on these big, large speeds, when you go through and you get people balancing the engine and they start pinching off these fuel valves and increasing the fuel manifold pressure in it, the pressure that was originally on it when you first program it may have increased by them restricting the flow of gas to it. So by looking at the fuel flow number, that will always stay pretty much the same. So we give you the option of picking either the flow to do your light off on or the actual pressure. So and it's, you can pick one or the other on it. So another really neat feature that's been added with some of the upgrades on it. Again, we talked about most of this. We require a mag pickup, a separate mag pickup. We don't really recommend, we never recommend running tagging another pickup onto this, because this is controlling the speed of the engine, so it needs to have its own pickup. It can either count the ring gear teeth, or you can drill the holes in the flywheel and you program the device to let you know how many teeth or holes are there. It runs on 24 volts. It can operate the speed either locally or remotely. And then, like I said earlier, you can clear the warm-up timer if you need to get it online in a hurry. So again, the way we talked about, there's 3 different ways to control the speed on it. One from the display, one from the PLC or the DE4000, or you can go in with the RS-45 and the serial data, and you can control it that way. So. Control outputs on it. If the close when the cranking RPM is exceeded and purge timers expire, And this allows you to open up a switch to turn the fuel on from the block and bleed to get fuel flowing through this valve. So it's, again, a very important deal for the purging part of it there and to help calibrate the valve. So, and then we have two outputs on it. One can be calibrated for the fuel flow. It's a 4 to 20. And then one can be calibrated with a 4 to 20 for the with the RPM on it. So, and then all the other data can be brought in on the serial communication with the RS-45. In the 10, it's a smaller one. It's the one utilized mostly. Very few GOV50s are out and about out there, and normally if they are, they're because of the flow pressure or the flow supply pressure was low, so we needed a valve with a bigger poppet in it to get gas to the engine. So the 10 comes in either a 4-bolt flange or an 8-bolt flange. And then the 50 only comes in a 4-bolt flange.
Yeah, I think that's a misprint there too. It's a 4-bolt SAE flange.
Yes, it is. Okay. They have it up on top, but they're not showing it there at the bottom. Okay. And it can be ordered with or without the flow measurement option. The orifice plates is in the valve. It's just a if you order the fuel flow measurement portion of it there, it's just a program that needs to be downloaded into it to read that data is also. This just gives you a little bit of what the valve schematic part of it looks like. So. Theory of operation utilizes the inlet gas pressure or shop air as a muscle gas, like we talked to about that. And this allows the valve itself to operate on very low amperage. And the governor varies the flow to the engine by the orifice with the spring-loaded pop. And then, like I said earlier, if they lose power, the spring-loaded pop will shut the valve enough to shut the engine down. So, and like I say, by varying the poppet, you control the RPM to it up to the engine. It just moves back and forth, changing the orifice size in there. So, the speed set point can be set up using the display, like I said earlier, or an external PLC or DE4000. And this gives you a good illustration of the inside on it there. So you can see how the gas flows around the poppet. Then it has this heavy spring in it. If it happens to lose air pressure or fuel pressure, or if it needs to shut down, the spring will close off the poppet. And then this plate in here with the orifice, this is where we get the fuel flow from. We have two transducers on both sides of that measures the pressure on both sides and calculates that into a fuel number. So the valve does need maintenance once in a great while, but they've been out there for years running without any problems on them at all. So. Depends on how clean the gas is. Or the air. Starting sequence in a stop condition. The engine will sense rotation of the flywheel, input of the mag pickup, and then we'll go through, like I said earlier, with the purge cycle. It will run on a timer for so many RPM, making sure it purges the engine of any fuel that may have leaked into it. And then when the timer is timed out, it will activate after the purge timer is out. Then it will go into the start mode on it, where we're triggered to open up the block and bleed valve to allow gas to come in to the valve, and then it's controlled by a pre-programmed fuel manifold pressure. Oops, jumping ahead here. And then we have a warm-up timer on it. Again, that can be, if the engine has already been warmed up, it can be triggered internally to shut off, or you can do it from the keypad. Then it will go right into the run mode on it. So then you can dump in the RPM you're looking for and get it up to speed. So. Governor will limit the rate at which the fuel pressure is increased when going from the fuel pressure regulator mode at the startup into the governor mode. So that's sort of the unique thing about the valve. It's one valve, but it does two different things and has two different setup patterns when you program it. So then after it gets in the governor mode, this allows a hard starting engine like a White Superior or Clark, like we talked about, to get online and to a minimum speed very efficiently. And we talked about that earlier there, that these engines require very, very low light-off pressure. A Dela valve is another one that starts off like 3/4 of a pound of gas. And this valve by itself can be set up to do that very well. So governing once the engine is at operating speed, the governor switches to governor operation and adjusts fuel flow for changes in engine load to maintain the program speed set point. So. And then the fuel part up there, we talked about that. That's is an option that comes with the valve. Again, we require the piping to be fairly straight in and out of that to give us a good, accurate reading on that. And it also can be calibrated with the controls in the valve there. If you have a way of measuring the fuel, with the fuel gas going into it, maybe on another source at the plant somewhere, then you can calibrate the valve for that. So, and then these numbers can be used for either calculating horsepower or torque calculations on the engine. So, the display itself will read the RPM of the engine. It will read the fuel gas pressure and the fuel, also the fuel supply pressure. The actuator output number this is like a stepper valve that we have on our EPCs, but this one here runs from 0 to 4,095. So it's got a lot of area in there as this poppet moves back and forth. And if you get into the computer programmer part of it, we have some really nice software there that you can see that when you're tuning the valve, how all that stuff moves around in there and the graphics and stuff in it. So if you are setting one of these up, I highly recommend using our program to do that, not just the keypad. So Now it has a 4 to 20 output that you can bring into another device to read the RPM on it. You just have to do the scaling on it. And it also has a air manifold pressure place to read that also, and that's an optional thing that can be programmed into it. I don't know if a lot of people are using that, but because they usually pick off that pressure off another transducer inside the panel somewhere. So fuel temperature is from an internal RTD in there, and then fuel flow will either read in cubic feet per minute or cubic feet per revolution. So again, that's another device that could be used for calculating horsepower. So again, we talked about if you did not want to use the display and bring it into a PLC of some sort or a SCADA system, you can use the Modbus register numbers to do that. So these are some of the shutdown functions that come with it. Would be low RPM, low fuel supply pressure, abort on the fuel manifold pressure, engine overspeed, and high fuel manifold pressure. These are all things that need to be programmed into the valve for safety purposes, for shutdown, and make sure that the valve doesn't get out of control. So, and these will all come up on your keypad there if anything does go wrong. So, now this is really hard to see, but this is the list of information that needs to be loaded into the valve. And again, I don't know how to make it any larger, but one of the things nice about this worksheet is that we give you suggestions on where to start. In a lot of these, when you put them in there, you don't usually have to modify them too much. A lot of them you can leave alone, but I believe there's over 60 different entries to go into that on it to get you set up on it. So usually have to adjust the gain, the kick, of course, the gear teeth, things along that line there. But a lot of the stuff that's programmed into our suggestions that we give you we usually can leave that alone. So they're not that complicated to get set up, even though it may look like that to start out. And where I say we're here to help in any way necessary to get you up and running on that. So the summary of that valve of the AG or the GOV10 is it's easier, more reliable starting, automatic ramping, the speed, precision speed control at all loads, reduces maintenance, self-diagnostic, and safety shutdowns. It's Modbus and 4 to 20 communication, and it has an optional flow measurement on it. So I say the whole valve. It's all the programming, everything like that. It doesn't need again any outside source to help it. It's a standalone valve that extremely accurate and really makes a big improvement over the old mechanical linkages and hydraulic governors. So now we're going to jump to our AGV5 valve. That's a little simpler. It has no controlling capability internally on itself, so it can be tied into a PLC or another device of some sort to operate the valve to give it the smart part of it. So it's an affordable valve, very durable. Very few parts in it to wear out, or there's no internal muscle gas in it. It's done with a big voice coil. It draws around 5 amps to operate it. It's quite a powerful valve. So, and it's probably the one used mostly in the field. They have companies with the PLCs or some type of supervisory control system in it. So. And a servo-based electric fuel valve eliminates the mechanical fuel valves, actuators, and linkages. Again, it does away with the hydraulic governors, even the Singer valves out there. It's a good fit for those because they still require an I2P, a lot of tubing lines. There's a lot to go with a Singer control valve. Well, this is a good, clean fit for that. So you just run the 4-20 right to the valve instead of running into the I2P on it. So allows. Go ahead.
Be a good application for our new air fuel controller too coming out.
Yes, also that's a good point there. We're coming out with a new AFR 500 fuel ratio controller. That this would be an awesome add-on to that. So that would talk to it directly. So again, it requires about 5 amps to operate it. So it takes more power than the GOV10 does, but it's extremely fast operating. It's also Class 1 Division 1 and Group 2 in a hazardous area. It's also spring-loaded, so if you do lose the power to it, the valve goes closed and we'll shut the engine down. Again, it's still not considered a shutoff valve. We still recommend using some type of valve upstream of that or downstream of that, one way or the other, to shut the engine down, like a block and bleed of some sort. We do not recommend using this as a complete shutoff valve. So, here's a little bit of layout on it. You run 24 volts to it, then you run a 4-20 to it to control it. And it also has a 4-20 feed out that will tell you the positioning of the valve. And that's being utilized more and more as we get into these PLCs and other type of computer devices. It requires a speed input. Again, like I said earlier, we don't recommend tying this to another speed pickup. It should be a standalone pickup. This is actually controlling the speed of the engine. So it reads, has a little transducer in it that will read header pressure internally also. We're also adding the cannon plug to it now. This is the only way you can buy the valve if it's new, because what's been happening in the past, people take the cover off and they move the board, the computer board inside of it, and it throws off the calibration on the output positioner on it. So it has to be sent back to the factory or back to some of the distributors to have it recalibrated. So this will come with the valve now if you order any new valves on it. So it makes it a lot cleaner to if you need to replace it or send it in for service than getting inside of it and disconnecting the wires and stuff on it. So this output here is what it's talking about here. There's a pin that runs up inside the board that moves back and forth in it or up and down in it, and that board has a coil around it, and if that clearance gets out of whack on it, it gives you a false reading on the output on it. So please, unless you know how to calibrate one, don't get in there and move that board around if you plan on using that part of the feature. Gives you the dimension of it. Again, I mentioned earlier there's a 1A and there's a 2A, and what it is just there's a larger orifice in the 2A, and again we've updated that here a few years back to make it even larger. So if you do think that's an issue, please get a hold of me or Tom Smith or somebody and with a serial number, and we can let you know if that valve has been brought up to today's dimensions on it or not. So again, it runs off of 4-20 from some internal device, either a PLC or we have a Gov Plus that I'm going to mention a little bit here at the end that will also control this valve also if you don't have a outside source of a supervisory controller on it. So again, it's a poppet valve with a signal that comes back if you can use that for to let you know the valve is actually operating in it. So it's a very nice feature to use. So. And this gives you a little cutaway on it. And the board I'm talking about there is you see these boards in here, and this is a pin that will move up and down in around these boards here. So if these boards get moved at all because you loosen up the screws on it, it knocks off the calibration of this positioner. So keep that in mind. And we made some type of modification down here where it flows more gas on the dash 2 valves. So again, if that's something you think you could look into and see whether or not if your valves have the latest modification that can do that. So, and a very simple valve that works extremely well. It's a very fast operating valve. So it's pretty much maintenance free. The only thing I've seen in this where they were doing some welding on the piping, the gas piping, and we ended up getting some welding slag in here once, so the engine wouldn't start. But otherwise, they run for years without any problems. So this is type it eliminates. This is a picture of a Singer valve that would run on an I2P. So the panel would put a 4-20 in the I2P, and then you'd have to come across the floor into this little regulator here as a booster regulator to put air into this regulator that actually controls a valve that's on the back side of this. So you just an example of I mean, you're controlling it from the panel that's across the floor, and then you've got to go through all these tubing lines to get to actually controlling the valve. So the idea of trying to get a good stable engine when you have all this parts moving around, it's just not a practical way of doing it. So with the other valve, with the AGV5, would bolt in the same area, and then you run a 4-20 right to the valve. So it's any kind of adjustments that the panel's making, you get it immediately to the valve. So it's a very, very good improvement over upgrade from these older type systems. And these have been in just to replace the hydraulic portion of it. So these are, the second version of what was on there originally. So again, it's a very great improvement on it. So, and it does tolerate the valve itself, since there is no muscle gas in it. It does tolerate a lot of dirty gas and stuff going through it, because there's not anything that gets in the control portion of it there. So it can handle a lot of our good pipeline quality gas that we talk about. So without any problems. Now, this one I add to the end here a little bit, then I'll turn it over to Curtis. This is a device that's been out for quite some time now. I'm guessing the last 5-6 years, I believe. And this is a good add-on to the AGV5. It puts out a 4-20 to an actuator of some sort, and we have used them in the field a lot. And it's a good way to control that valve if you decide to go with the AGV5 over the GOV10. So it uses a lot of the same programming mechanisms that the GOV10 has in it. So it's a good add-on for that if you're looking for a way to control that. And this gives you a little bit of what the controller looks like, the Gov Plus. It's fairly easy to set up, and it's pretty easy to tune. So then it gives you a little bit of a work screen here as you're making the adjustments on it. You can actually see how stable the RPM and stuff on it as you do the tuning on it. So it's a nice little controller for that, or anything else that that you want to control with a 420 is to control the speed on. So, okay. Thanks for your time, and now I'll go ahead and, if you have any questions, feel free now, or we'll turn it over to Curtis. So,
You could have got at least 10 more minutes out of this, couldn't you?
I'm hoping you're gonna do your job. So,
Hi, Mike. Okay,
Okay.
this is, most of the time, while we are just experiencing that from the factory, they didn't order these calibrations. Then the customer is demanding for the calibration stuff. Then we just are just breaking with only with some codes to get it, because already verifies everything already there in the GOV10 itself. But for the fuel flow measurements, we need those code to break it and just enabling that one. So that part should be attended.
I didn't get all that, but I believe you're talking about to measure the fuel flow as far as getting the information to do that.
Yes, because it is the already orifice is there in the machine, everything, but only we need to enable that the fuel flow measurement. To enable that one, we need to get a code from factory. That is why always the customer is just everything there, but to break the code, we need something from the factory. That is
Yes,
that's
I do
separately
believe-
purchased, right? That's separately purchased. So that's done. That functionality is turned on at the factory. So is that?
Yeah.
I guess I'm not understanding the question.
Well,
Maybe I'm missing something.
To enable the fuel flow function to communicate with the valve, typically it's to the 232-485 converter like we do most everything else. I'm not sure what the other cable is you're talking about, if you're talking about that. Me personally, I haven't enabled one. I believe it was just a code that you put in. And if I'm not mistaken, I think you could do it straight through the 485. But we could check on that for you.
okay. Yep.
No, it's got to be done through the display. It is a code that's purchased from Altronic with the right serial number and information given. But it has to be done at the keypad where you put the code in and hit a sequence of buttons to turn it on.
Okay. Mike, can we look and see if we can find a procedure for that?
Yes, we'll figure that out. I'll get with Tom and
It's on the website under
Right.
the service bulletins.
okay. Okay, Curtis.
Let's see here. What do I want to do? Decent. I'm always challenged on this stuff, you know it? Anybody see that?
Not yet.
Mm-hmm.
I saw your mouse moving around, but now we're to your
About that.
home screen. Yeah, there you go. Now you're in.
Miracles. All right, a lot of y'all probably already seen this. We're going to try to cover a little bit of this AccuCom electronic governor for our carbureted engines. It's also a actuator that we can use standalone for any kind of position control. It's a 24 volt powered electric motor, basically DC. It has 5 amps on the power requirement, and that's something, you know, for your sales guys, we really need to pay attention to, because if we're selling against brand X, on that typically they have a little bit higher power requirement than we do. So I've seen some of them go up to, you know, nearly 20 amps on the competitors' products, which makes it a lot more desirable to stay with the 5 amp. speaking of competitors, we have a little bit, a small footprint that almost lines right up to the other one. It is about 8 pounds lighter than our competitors. We have the RS-485 communications terminal program, class 1 div 2 also. This product here was really developed to combat our competition. Our connections to it will line up with the Woodward product. So making a retrofit on it is pretty desirable to the customer.
Hey, Curtis.
Yes, sir.
We can't see your screen.
What happened?
I can see it. I can still see it, Curtis.
I can too.
Oh.
I can see it.
Yeah, I can see it.
We just have a black screen, so just want to let you know.
Oh. Well, I mean, you Colorado people, you sure it's that or something else?
I mean, we may have taken a trip somewhere, but that's,
All right. All right. So I want to quickly go through some applications. Everybody understand what this governor's for a carbureted type engine. The product that Michael was covering is for a fuel injected engine. Fuel injection engines don't typically have, well, let me back up. They do have linkage and everything, but they do not have carburetors. So we're going to be talking mostly about carbureted type engines and using a positioner. So on the application, let me get rid of Dave Bell's in my way here. Yeah.
Mind the way, Curtis.
Of course. It said DB right in the middle of my screen. So like I said, we'll typically replace a regular old mechanical governors, your Woodward UG8s and stuff like that. And why would we really want to replace those things? I mean, they've been out there for 50, 60 years, but we're starting to run into more environmental issues with the leaking hydraulic fluids and stuff. Our world's turning more to electronic on control. With the Woodward UG8, you'd have to put, maybe an air actuator type head on it to be able to control the speed with it. And with doing that, that's additional tubing. It's a device, an I to P or something to send pressure signals to those governors to be able to vary the speed. Well, with the electronic governor like the AccuCom, we can eliminate nearly all of that stuff. We can eliminate the linkage. We eliminate, tubing for pressure, whether it's gas or air. So we eliminate the environmental impact also with the oils and stuff, that's really driving this green New Deals and stuff like this. So what we did, we come up with this probably, 5 or 6 years ago. I think Herbiger developed this for Yenbacher engines even before that for their own specific applications. We took it and we adapted it to this situation. So does everybody understand really what we're doing? We're wanting to control the speed of an engine with electronic governor. So that's basically what all this thing is for. We also can use it for a position controller. When I say position controller in our industry and stuff, we typically would think about maybe a wastegate controller like we're using on some of our lean burn, clean burn superior engines, some of the Cooper engines. I know there's a few that's put them on. I know GCS has put on a few, and Mr. Swilley's put on a few over Sulzer using wastegate controls. So typically when we see that on a wastegate, especially a hot bypass, we think about heat and stuff. And from where I stand, I have not seen a failure due to heat. What about you, Kenneth? I know you had that one mounted underneath the hot bypass. Is that thing been holding up pretty good? If you say no,
Yes.
I'm gonna get you.
No issues.
Good. So with that control,
haven't had any issues with it at all.
well, that's great. I know we had some concerns. Well, we've been testing this thing for some years now, and I checked with our repair department, and this is very minimum of anything that's even come in. So just speaking on that wastegate control, that's a good application to add with your EPC 250 stuff, and with that. So if you're quoting an EPC 250, instead of adding the I2P into your panel and then maybe going out and outsourcing a new valve or something that's going to control that wastegate, you have a product right here that will work in that application. Also on here I put restrictor valve. That's the same application in just a different way of looking at it. Wastegate wastes air, restrictor valve restricts the air going to the engine. We have a many on engines controlling small louvers on like 3,300 cats. They're controlling those louvers basically off their jacket water temperature, and they're working very, very well on that application. Valve actuators, we could probably shut or open a valve. It just depends on the force that's needed to. Like I said, we only have about 8 Newton meters worth of pressure to open and shut. So if you ever get to that situation, we probably need to talk about it before. And then, like I said, we use it for speed control also. I'm just going to throw a few pictures out here. These are probably some old ones that you've seen before. This was our competition, ProAct. We went and put this on, I don't know how many years ago. So we took the ProAct off and we put the AccuCom on. This is one of the very first AccuComs that went out as a test unit. It is still running today. It only has like 3 bolts under it that would match up because it's a little bit different from the Woodward. Also, there's always been some questions about these flex couplings, about them breaking and stuff. This one, to my knowledge, is still in service also. This is on 8G. You notice we're hooked right directly to the butterfly shaft of the carburetor. So all the linkage is, it's gone. So that linkage is a maintenance item for these guys. You have a lot of your joints and stuff that needs lubrication changed out or whatever. This is on a Waukesha 7042. We had a PLC on this that we put on many, many years ago, about 25 years ago, that we would operate a Kinetrol actuator to control the speed. With the PLC, basically we had to run it through an I2P, and then the I2P run to the actuator, and then we control the speed. It worked pretty good. But we turned around, we put this AccuCom on, we got rid of the I2P, we got rid of the air signal going to it, and plus we got rid of any of that little bit of linkage that was back there. Because we had all of this linkage right here that, like I said, it's still a maintenance with all your Heinzman joints and all that stuff. We direct mounted this thing. This is a bracket that I can't remember who fabricated it. This is on a 3500 TLA non-atom 3516 cat that we mounted in the shaft. This was in the valley. This was another one of our tests because we really wanted to see how it would hold up with the heat. It's still running today. This is one of Oklahoma GCS deals. Here's a few more other pictures of it. This is on an 8G825 split manifold. So basically you have 2 valves that we're going to operate. We had this linkage operating the top valve, the second one operating the bottom valve. This is one that is a straight manifold off of 8G also. I'm going pretty quick at this, so just stop me when you can. The Siemens PLC controls this one. So mainly with one of our customers, they do all their governor control through their PLC. But before they were using a Kinetro type valve sending the signal through I to P to it. So they found this real desirable to change. Plus we're doing some suction versus RPM on the control on that. This is another Walker-Shaw 7042. We have an Altronic DE3000. It's doing the suction versus RPM. I'm not going to tell you who installed that, but he'll get mad at me. So, but notice no linkage on this one either. 1197, 1800 RPM engine. This real nice little setup that X-Line put on. Looks very, very nice. Operates good still today. They run a remote set point from their control facility downtown on these engines.
Recording is on.
All right, we're recording now. So. Okay, here's a wastegate control, and this is on a 16 SGTB or 12 SGTB, about the same difference. We mounted the AccuCom down on the intercooler, and then just run the linkage up. Main reason we really did this because it's kind of difficult to mount to that flange. I know we could probably come up with something, but we ran the linkage. It seemed to be working just fine using EPC 250 on it. Here's the number one thing with this thing. This is our communication box. I know it looks real familiar to everybody. And I guarantee everybody that's done these has had problems with, they'll be programming the AccuCom and all of a sudden they just lose connections with it. Has anybody run across that?
Yes, we have.
These things seem to wear out though. On about 4 different situations I run into that just kept kicking it off. You know, they get right back on and run, start programming, kick it right back off. When we went to the newer style, that issue's just gone away. For me, is there everybody still having that type of issue or anything?
I've had one of the new ones start doing the same thing after a while.
Really? I don't know what's in there. If it's something that's, I'm sure the communication probably has some kind of isolation barrier or something in there that's probably getting wore out or damaged or something. Just because we're not real nice to these converters anyway. So I always try to keep an extra one just in case. So we'll go from there. So basically, that's just a quick run through of what the AccuCom is and kind of the application. What I would like to do here, if we got some time here, let me escape off this and then just pull up the actual. Everybody's
Yeah.
Can everybody see that?
Yep.
All right. So I keep a little demo tool, I guess you could call it, that I built up here at my house and stuff that I can run a lot of the control scenarios that y'all seeing. So if you run into an issue and something's not happening right, a lot of times you can send me your config files and stuff on this, and I can actually test it here. I know I've done a few for X-Line and a few for GCS and stuff, but it seems to work. Like on this one system here, I think somebody asked me to kind of go through the setup on these things, and I can't touch on everything, but we can just start from the very first here. Let me back off of this thing and disconnect real quick, and we're going to make this quick. I know we're running over time, so let me see if I can. I'll disconnect to it here. So basically, when you'd hook up to this, a lot of times this interface number is going to be something different. You need to find out what port your device is hooked up to on your 232.485. Typically, mine's always on 4, so that's the one I use. Do not mess with any of this baud rate, parities, or anything like this, or even the slaves. If somebody's communicating with this and you probably need to get their slave ID, there is a way to get it through the reset function, but I think it'd be easier, just to ask them to give you that slave ID number, especially if you want to get onto it. So I'm going to connect to it. Typically it says device is currently online, and it asked me if I wanted to read the data that's on it. I always hit yes on this. I hit yes on this mostly because I'll get the offset numbers that's in our position. Like I have an offset angle of 169.4. This number is very important. I know at the first we'd always say, heck, it don't matter, 0, whatever and stuff. But I found that, you need to put this offset number. It's printed on top of the governor, right by the serial number. This is a number that we need to be putting in here. And let me back up. To be able to put these numbers in here, we have this tab here. It says login. All of our login that I've ever dealt with, and I'll tell everybody else to deal with, that the password is expert. In all caps, all caps. There's some things in this governor that you don't have to save. There's some things that you do have to save. So I log in and I save everything because I'm not smart enough to remember which ones you do and you don't. We have this little deal over here on the right that says save not needed, but I'm old roughneck. I don't trust it. So I save everything when I'm doing it. Okay, so we have our speed set points. We can have a rated where you could just do a rated number and you bring it right up with a toggle switch or something at the sort. We have an idle rated, which we can bring it up to an idle RPM and then flip a switch and bring it on up to a load RPM if we wanted to for the idle rated. So like here it says rated 5 or 900. We have an idle 850. Basically we'd start it. It'll sit there at 850 and then when you go to rated it goes to 900. On this application I'm using a 900 because you have modifiers here that will override about everything that 900 will do. So these things they're easy to manipulate, but they'll drive you crazy all at the same time. We can do some different startups, some different ramps and stuff if we wanted to. Say you wanted to do a different startup with maybe a different type of fuel or something. You could ground out one of our digital inputs and says, hey, go to my number 1 selected rated or go to number 2 selected rated. I have never used this yet, but then again, I only deal mainly, with gas compression or pump type engines. So we have a rated set point, acceleration, ramps. That's how fast it'll go up to this set point. Deceleration, how fast you drop. Pretty simple. Idle rated. It shows you what input you'd have to touch or ground or add 24 volt to. We'll get to that real quick. Then we have a ramp to idle. Basically it says when you're going back down to the idle RPM, even coming off rated or whatever, it'll just ramp down pretty slow instead of just hammering it down. Fuel limiting. I haven't really messed with any of the fuel limiting or transits or nothing, or the boost limiting. I haven't run into that application in this. If any of y'all do, and then we'll try to address it then. Alarm shutdowns. I typically don't like to have any of my alarms on my governor. The only thing that I would worry about as far as governor is overspeeding or anything like that, or maybe missing its gear teeth. If you get to know your operation page, you can almost troubleshoot it just by watching this page do something if you need to. Control is a pretty important page that we have to deal with. Your run enable input selection. Your run enable is probably one of the first most important things you have to do. We have to tell the governor, hey, it's time to go, wake up or whatever. With this input is what you do that with. That's our run enable that says, hey, let's go. Our engine starting settings. You have start thresholds. Says don't do nothing until I get to certain. Either runs threshold, it won't go. It'll stay in the start until it hits whatever you put in here. Then it'll go into a run. So A start threshold, it says, oh, if I say 100 RPMs, I'm trying to start, basically. Your hysteresis is your change of everything, your start fuel. So on our GOV, we can say, hey, I want an actuator kick to open my valve up so far because I need a little bit more fuel right when we start. We can use this the same way. If we start at 0 position, like with the carburetor always closed, and then we try to ramp up, maybe we're in a situation where we don't have that much starting air or something like that. We don't want to run our starters very long. You can say, well, jump it up to 20%, 30%, whatever. Let's get that fuel to it real quick, and then just bring it on up. It's kind of like a little, actuator cheat. Max starting time, just like it says, if it don't start in 120 seconds, shut it off. Run speed threshold, when the governor goes into run, when it says I'm running or self-sustaining, that's the RPM it typically does that with. Engine stopping settings, you have power down times and seconds. Your stop speed threshold, if it gets like within 100 RPMs, difference of stuff, we can stop it. Power down current, hold and current, which I never mess with any of that. Stop state delay. Governor error, here's where your RPM and times. If it stays, I believe it's the way this reads at say 150 RPM difference at a certain amount of time, it's going to shut you down. So if you're supposed to be at 500 RPM and you're running at 300, it's going to start counting in 30 seconds. If you don't get it up within 149 RPM of that set point, it's going to shut you down. Governor high air range, same thing. Overspeed threshold, that's just where you put your overspeed in. Shaft behavior, you can de-energize this thing whenever it gets a fault, or you can leave it powered up. On my demo, I always de-energize it. That way I can hear it. A lot of people leave them powered up. If you're on purchase power, there's no big deal. Leave it powered up. But if you're on battery backup and stuff, I would de-energize it just to keep from running your batteries down. Dynamics, you can do some PID changes and stuff if you want to try to tune this thing in a little bit better. There's a lot of different scenarios that you could do. I haven't done a whole lot of that. Haven't needed to too much. So I know some of y'all have done some PID stuff, especially on some generator applications. Speaking of generators, we're really the droop and all that stuff really hasn't been. How did the Swedes explain to me? Implemented into this, but it's there. So you take that, how we can. Position. Like I said a while ago, we have an offset angle. That's the number on top of the governor. I use the position and the calibration kind of the same deal. Since the operating angle's here, that's the first thing you're going to say is, well, where you get that? All that comes from is this calibration mode. So right now, like on this unit I got on my desk, let's see, I think it's on. If I hit enter cal mode, you tell it what position or what rotation that you're in. If you picked up this governor and you looked at the shaft of it, that's the rotation, whichever way you turn it should be. Like if you're looking at the shaft and you turn it to the right, that's clockwise. If you turn it to the left, it would be counterclockwise. I've seen these though where they would not take this position or give you a number that's really crazy fictitious. Like I didn't turn that thing 300 something, degrees. Well, I've had to cycle the power on them before and it seemed to clear that up. I don't know why it's done that, but just a few of them I've seen do that. Especially if I do not read the program that's in it whenever I communicate with it. So right now I just set it and I want to catch it. Now I'm going to turn it and then I'll catch it again. So I just calibrated mine. I got 156 degrees worth of angle on my demo sitting here on my desk. Now, whenever I set them up, you know, you can go to full close and then all the way to full open. Everybody says, well, I want to come off of it a little bit. I don't want it hitting my butterflies, you know, sticking or anything like that. Right here on the soft stop, minimum, soft stop max, you can actually keep it from hitting it right here. The default on these is usually like 5 and I think it's 98 or 95. So what that does, it will stop at 5% before you get to that bottom where you calibrated it at. I've used that also. If I don't have enough fuel, I can ease it open a little bit more, you know, 2 or 3 more percent. Sometimes it would be fine. But typically that's not the correct way to do it. Another thing I think is kind of important on these PIDs, I haven't really had to mess with those hardly at all. But the one thing I have messed with, if you notice, this thing seems pretty violent. Whenever you energize it or run enable, you see that thing just slap open or slap shut. Y'all seen that out there in the field? Well, I found if I set this thing at a -10, all of that goes away. It just goes so much smoother. Crazy. I don't know why, and I can't get a good answer out of it yet, but, you know, I guess the guys, they're sleeping when I'm awake over there, I guess. So I'll set that speed limit at a -10, and it's a nice smooth transition from open to shut when you hit that run and enable. Mag pickup. There is an equation in the book that you have to fill out to get all these averages and stuff. These numbers I have in here is because I run a signal generator for my demo. So these need to be pretty close to right. I've noticed that on some applications we've had some issues with picking up the gear teeth right. These tooth-to-tooth tolerances seem to do have some effect on how your pickup reads on some gear teeth. And your low pass filter also, I think X-Line, was that right, Michael? The last thing they had was on this.
Some issues, the holes in the flywheel weren't large enough, and this thing was missing some of the holes. So we had to do some modifications like that to get it to where it was more sensitive. On the holes in the flywheel, I believe that's what we ended up doing. But it wasn't giving us
low pass filter. Yeah.
Yeah.
Yeah, it was like 200 RPM off or something like that. So
maybe not quite that far, but in that area, yes.
Okay.
And we tried 3 different devices, figuring the devices were bad, and they all read the same. So we got into making a modification, but all about the holes weren't large enough to see that pickup. So,
well, this would be a lot easier to mess with than drilling holes and changing AccuComs. So.
Right.
Your analog I/O, basically it's your 4 to 20. You can set your 4 milliamp at what percent on your movement, 20 the same. You can run a 0 to 5 if you like, or 4 to 20, or none at all. All of that comes with doing any kind of speed versus RPM, sending a 4 to 20 signal or 0 to 5 signal to modify the RPM going to the engine. Output, the same thing. You can do a position. If you want to feed back to maybe a PLC, they'll say, a position feedback at 5% or 95% is open and shut, or the actual position off the 4 to 20, the same thing. Or you can just do actual speed. It says, 0 to 400 on the output current of it. So anytime they're coming back to the control room or something, they want to see that speed, you could use this as a device to do that also. We went through the calibration part, modifier parts. A lot of the times this will drive you some crazy. The droop on this, I was told it's not functional. So don't be doing load shares or anything like that for the generation market or generator market. Your bias, of course, none is none. You can do a raise and lower. So on your raise and lower switch, if you're just doing a rated deal, we could raise and lower the RPM just by a switch, up or down. Your analog, if we were just sending a straight analog signal to it, we could send it, which I always use the analog or raise and lower on it. So basically, when I raise it or lower it on these inputs or send it to 4 to 20, I can cover all my bases on it. Your discretes, these are your inputs to the governor that tells it what to do. So on input number 1 that I have it as a high switch. What a high switch means is I'm going to send it a 24 volt DC signal, or I'm going to take it away. A low switch is I'm going to send it a ground signal, or I'm going to take it away. When I send it or take it away, it's through this active open and close. See how the switch closed and it opened? Just whichever state that your controllers are in to send that signal, you can manipulate this instead of rewiring a relay or whatever you're going to do. All these letters here, they represent the wire labels on your harnesses. You can change some of these up, but it's pretty customizable to whatever you want. Output configuration, I can do an output on certain shutdowns. If say I'm sending it a 4 to 20, I can say I want to flag it if I got too much milliamps on it. So if I go to 25 milliamps, it's going to flag it, shut you down, and go from there. So typically I don't use the shutdowns off of this. If you need to, they're there to use if you needed them. We don't mess with our advanced stuff. This is where we can reset the calibration of the governor. I suggest not messing with that unless it's through factory support or somebody. So for a little quick deal here, I'm just going to, for greens real fast, I know we're a little bit over time. I'm going to give it the run enable signal. See the light would come on, and I want to give it a little bit of RPM if it's going to work for me. Remember, I got to get over the threshold for it which run. If you look at the actuator output, you see I'm supposed to be getting up to 850, and see how this is where I should be going. My actual position of my actuator is all the way open because I'm falling behind right here. So let me see if I can catch up real quick. Probably work if I went. Whoa. So that now that I've overshot it, you see it's looking for 850. Now my actuator's shutting off because I'm over it. Basically, guys, that's all it is a cruise control on a car. We're trying to maintain a certain RPM, and by opening and shutting the carburetor. That's what we're doing. We have a speed input with the magnetic pickup. We go from there. So right now I'm on idle. See, my idle rated is not lit up. If I hit it, now I had that rated at 900 right here. Now it wants to go to 900. Well, I'm not at 900. See how it's starting to open up again, trying to give it some more fuel because I'm below on my set point. So I can, let me add some RPM to it, and I want to shoot over it. It's at 960. Guess what? Now I'm turning around, I'm shutting it off. And you've noticed the farther away you get, the faster it's going to react from that set point. All right. So remember we had the modifiers here for a 4 to 20. So right now my modifiers were set at a minimum 1400 to 1800. I'll go back to my operation page and we'll look. This should be going to 1400 because I'm at basically 4 milliamps. I took that low milliamp and high milliamp shutdown off, basically that deal. So here I am at 1400. I'm not there. My governor, it's basically all the way open because why am I only at 94, say 95% open? I'm only at 94% open because I told it on this position that I got a soft stop at the top end at 95. So if I went to 98, say I didn't have any fuel, and I send it to that device, go back to my operation. Now this thing jumped up to 98. It gave me a little bit more fuel. So I've had some calls from some guys that's had this set at like 80 something before, and they said, well, I can't run my engine fast enough. I said, well, it's either you got to give it more fuel or you got to give it more actuator, one or the other. So right now I'm at 1400 and I'm only at 900. My governor's all the way open. So quickly I'm just going to bring my RPM up. It's at 1200 now, 1400. Well, I overshot it a little bit. 1600. There we go. We're shutting it off. Basically, guys, that's it in a nutshell. If you get a chance to build your little demo or something like this, we actually have one that we did build for a customer that Greg Grubbs and them probably have the prints and everything on. It's a handy little tool. It sure does explain a lot, especially with your service guys out in the field. If they're beating their head up against the wall on something, you can simulate a lot, and I think it'll help you out. But basically, that's all I got right now. Got any questions?
Good stuff, Curtis. Questions for anybody? From anybody for Curtis?
I just got a quick question. The dynamics adjustments, does that take effect automatically, or is it going to, you have to save it or load it up to the control every time?
Like I said earlier, I'll always save it every time. I mean, if you're running, they will take effect. I'm trying to think how I could test that real quick. I don't know. I mean, on your dynamics, that's basically going to be real-time engine adjustments. But I believe if you're taking, as long as you're logged in, and if you change them, and I always take the action, just go ahead and send it to the device. It should take effect then. So then I'll save it to the device, and I know it's going to still be there. Let's see. So it should still be there, even if you cycle power or anything also.
Right. Outside, but when you're tuning, when I'm tuning an engine and we're trying to smooth it out, as I'm making adjustments, like on the Woodward, as I'm making adjustments to the dynamics, it's automatically taking effect into the actuator to smooth out the engine, and then I save after I get the engine calmed down.
Okay.
To do the same thing with the AccuCom, or is it something that when I make a change on the integral, I have to save it and then it takes effect in the engine to make a change?
On some other inputs I've seen, as soon as I do it, not even save it, it will take the change.
Okay.
So, like I said, it's kind of hard to tell unless you're actually on the engine. Have you seen it not accept it or just not make a big difference?
I've seen it where it didn't make a big difference while I was trying to adjust it until I went ahead and saved it, and then it made a big adjustment. And then trying to stabilize the engine, sometimes I'll get a little out of the window trying to stabilize it, thinking it's taking effect, and it's not. So it's why I was just kind of curious. I know they were updating and changing things over. This was towards the beginning, so
right.
I was just kind of curious about that. Most of the time now, I've been putting them on. I've been using them as positioners rather than controllers.
Right, letting the PLC do all your gains and everything.
Right.
Yeah. Even while we're on that real quick, I know we're kind of crunched for time a little bit, but let's see. Yeah, I mean, I haven't had play with the dynamics all that much on the applications I'm dealing with mostly. Seems like everything that maybe I'm just golden or something, but typically, they hold within a RPM or less. Sometimes it's just real tight. I've seen some situations, and that's probably some of the guys that's on here that actually doing a speed versus suction where it would hold within 2 RPM, and that's using a 0 to 100-pound transducer that's reading like 2 pounds of suction, and it's still holding it. So I haven't done a lot of the dynamic changes, but I would have to play with it to see if I could figure out, if those dynamic changes are affected only in the save mode or not. So sorry I couldn't answer that a little bit better.